In this video, I want to show you how you can fetch stream data using Weather API, handle the stream data using Kafka, and finally use Spark to consume and process the data. As a bonus, we're also going to use Grafana and other related tools to monitor the behavior of Kafka parameters and status. I'll gather the code and configurations needed in one place in a GitHub repo and then put it in the repos link in the description. Before going into the details, let's review the big picture together. In the very first step, we fetch the weather data using HTTP GET method. Then we need to use a Kafka producer to queue the data. Here we're using the Python Kafka module to fetch data and create the Kafka producer. Also, you need to pay attention that we need to have Zookeeper running behind the scenes to make Kafka work. Zookeeper is basically responsible for managing the Kafka workers. Now we use Spark here to consume the stream data from Kafka and run our queries and processes on the data as it comes. Also, the Spark lib in Python has been used to create the Spark consumers. Now, as a bonus, we want to set up Grafana, but first we need the Kafka exporter tool to extract Kafka metrics and then Prometheus to read the metrics and serialize it for Grafana. Okay, with this big picture in mind, let's start implementing each piece one by one. Remember that here I'm using macOS, so if you're using Windows or Linux, the commands and installations could be a little bit different, but the whole idea is pretty much the same. With a little bit of searching, I'm pretty sure you can find the right solution for your issues. Step 1. Before anything, make sure you have Python and JVM installed on your machine. Java machines are essential because Kafka and Spark are based on Java. Installing Java is a bit different from OS to OS, but with a little bit of searching on the internet or visiting the main website of Java, you can install it properly. For instance, on macOS, simply you can install it using Brew Package Manager. After making sure you have Python installed on your machine, create a Python virtual environment using venv or virtual env. Then we need to install necessary modules like Kafka Python and PySpark. We also need the requests module to call the Weather API and fetch the data. However, the best way to install Kafka Python module is through a related Git repo as shown here. There is a good chance that we also need to install some other modules like 6. You can check the list of modules in the requirements.txt file in the repo. Now, the first Python script we need is for fetching the data and creating the Kafka producer. You can simply grab the code from the GitHub repo. I'm not going to write the code line by line, but let me explain the important parts of the producer code. The first function we have created is for fetching the data using the Weather API. We need a source of data to stream it in the first place. So we use Weather API, which is free of charge. You just need to sign up and get the API key. Then put the key in the right place in the code. In order to have new data at each call, here an API used to get weather info for random locations around the world. So here we're using another function for generating random coordinates, then passing the latitude and longitude to the API. The final part for this script is the Kafka producer. So here we fetch the API data and then queue the data so that the consumer can use the data. Step 2. It's time to install Kafka itself. Installing it is a bit different from OS to OS. On macOS, if you have Brew Manager installed, it's pretty easy. Just try brew install Kafka. That way, it also installs Zookeeper, which is necessary for Kafka. However, in the latest versions of Kafka, you don't need Zookeeper anymore, and you can use an internal tool called Craft. But since Zookeeper is still a main choice for many projects, we continue with that. After the installation, we can simply run the Kafka server using the printed command. Basically, it's Kafka server start command, along with the server properties, which we'll look into later. Now let's run Zookeeper server along with the default configuration existing in the installation path. Correct configuration of Kafka, Zookeeper, and Spark to enable them to communicate correctly could be challenging, and you might face different issues that you need to fix. So be patient and try to search for the solution. For instance, here when I try to run Kafka server again, I ran into this issue. It says another Kafka instance is using the logs directory and hence there is a log on that file. So the solution here is to remove that file. Then if I try to run it again, it runs into another problem. This time assigning the ID to the Kafka broker phase. Apparently there is another broker running with the same ID. Here Zookeeper comes into the picture, where we can check the running brokers. So we can go to the Zookeeper shell on the right port, which is by default 2181. Then we can see the list of Kafka brokers with ls command. Apparently there is already a broker with ID 0. One way to solve this is going to the Kafka server properties and try to change the broker ID to a desired ID, or use -1 to make it choose the ID dynamically. There is a chance that even after this, you face some other issues. Like here, the default port that Kafka server is using is occupied by other services. So we can change the port in the configuration file to fix this issue. Let's start the Kafka server with the updated config for the last time. Well, it seems to be running well. At any point, if you run into an issue, the first solution is always trying to find and kill the related ports for the servers and restart the needed servers. Now that we have the Kafka and Zookeeper servers running, let's run the producer Python script we have already created. As you can see, it fetches the data every second and passes it to Kafka. Then Kafka streams the data for the consumers. Step 3. It's time to create our consumers to use the data streamed by Kafka. Here we use a Spark for that purpose. Again, you can just copy and paste the code from the repo, but let me explain the important parts of the code. The first part of the code is defining our data structure. Here we use Spark data types like integer, float, and string types. We can even have nested data structures like how we used here. Then we create a Spark session by assigning a name to that. Now we have the main part here, which is reading the stream data from Kafka. So the format should be Kafka. Then as the options, we need to pass the correct port of the Kafka server. By default, the port number is 9092. But if you can remember, we changed it to 9093 in the Kafka properties. Then we need to subscribe to a topic. For us, it's weather_topic. It's obvious that we can create multiple producers with different topic names and multiple consumers subscribing to different topics. That's basically the main job of the Kafka tool. Now that the data is in the form of a Spark data frame, we need to parse the Kafka messages. This is where we use the data structure we defined in the beginning of the script. When we have data parsed in the structure we want, we can perform our processings on them and store them on a DB or simply print them out as we have done here. Before executing this consumer script, first we need to make sure that the producer is running and streaming the data. Okay, it's time to run our consumer script to see what happens. Apparently, we have successfully set up everything correctly. On one hand, we fetch data and stream it using Kafka, and on the other hand, we're consuming the data using a Spark and showing it in the terminal. So far, we have configured Kafka and Spark and created our producer and consumer. Now we can add one more layer on top of that to monitor the performance of the Kafka and Spark workers. Step 4. We want to use Grafana to have a visualized dashboard showing the metrics and numbers. But first we need Prometheus to pull the metrics from the Kafka exporter tool and pass it to Grafana. Remember, here we're using Grafana to visualize the Kafka metrics, not the actual data. To show the actual data, we have other tools like a combination of Elasticsearch and Kibana, which I'll talk about in another video in future. So first, we need Kafka exporter to pull the metrics from Kafka and provide Prometheus with them. One way to install Kafka export is by going to its GitHub page and downloading the right package. Then unzip the package and just run the Kafka exporter file along with passing the Kafka server a port number. There is a chance that you need to fix the permissions through privacy settings in macOS. Okay, if the Kafka exporter server is running, it means everything works fine. Now it's time to install Prometheus and configure it to fetch the metrics from Kafka exporter. Simply in macOS, we can use brew install Prometheus. After installing Prometheus, the very first thing is to edit its configuration and put the correct port number of Kafka exporter. The only thing left to do is just to start Prometheus service by passing the config file as an argument. Now to make sure that Prometheus gets the metrics from Kafka exporter correctly, we just need to take a look at Prometheus dashboard, which is running on localhost port 9090/targets. There we shouldn't see any errors. As the final part, we need to install Grafana itself. For that, just go to the official website of Grafana and try to find a suitable version of your OS. You can install it either by manually downloading it or using the terminal commands. Here for macOS, I'm going to use brew installation, which is the easiest way. To check if the installation went through or not, simply we can log in into Grafana dashboard, which is running on localhost port 3000. The default username and password should be admin. Then it asks you to change the password. Okay, now we are inside the Grafana dashboard. The very first thing we need to do inside the Grafana dashboard is adding Prometheus as a data source. So go to the data sources section and add a new data source. We have different options to choose from. One option is Prometheus, so go ahead with that. Now use localhost port 9090 for the Prometheus server URL. Finally, click on Save and Test button. If Grafana can connect to Prometheus properly, you should see a successful message. Now you have several options to visualize the data. One is using one of the existing dashboard templates on the main website and inserting the dashboard using its ID. Another option is to create a dashboard from scratch. Here we just want to try to create a new dashboard and visualize one or two metrics. So after adding the source, just click on Build a Dashboard and then click on Add a Visualization button. Choose Prometheus and from metrics select the metric you want to visualize. For instance, here I'm going to visualize the duration of scrapes in seconds. And this is how it looks. Remember, using Grafana, we just visualize the metrics of the servers only to monitor their performance, not monitoring the actual data. Okay, I think that's it for this video. I hope you find it useful. See you soon with another quick demonstration like this.